Kubernetes and OpenShift in way too short of a time. Again, my name is JJ Asghar. I'm a developer advocate from the IBM cloud. And as you can see, I really do have the email address of awesome@ibm.com. You can get directly to me there, or you can find me on Twitter at JJ Asghar. Oops. Okay, so as I said, let's start with some building blocks. My ultimate goal is to show how easy it is to get a Python app to run on OpenShift. But in order to get there, we have to have the same vernacular and we have to have that understanding of how all the different pieces come together. So I'm going to start from the very ground up and then move forward. I will use the term OpenShift and Kubernetes interchangeably because, believe it or not, they're actually the same thing. OpenShift just has some really nice to haves on top of Kubernetes specifically, and I will make it very clear when it's specific to OpenShift and not to Kubernetes. Cool? I got a thumbs up, maybe? Anything? Probably not, because I'm talking to a webcam.
Okay. I like it. I'll tell you what, just so you can get some visual incentives here, I'm giving you the big thumbs up, JJ.
Perfect. Thank you. Thank you. Okay, so let's start at the very beginning, or start at the very bottom, which we need to talk about containers. So there are two main container players in the space right now, one called Podman and the other one called Docker. This is a nice little call out to my marketing team because they informed me that I can't use the Docker logo because of branding rules. So of course I'm yelling at the cloud. There are multiple offerings out there. There's Builda, there's Podman, there's Docker. They all adhere to something called the OCI spec, which is the Open Container Initiative, I believe. So as long as it adheres to that spec, that is considered a container. You need some type of registry, something like Docker Hub or Quay, where most people use Docker Hub by default now, but due to the, what's the word I'm looking for? Pull limits and the limitations that Docker has done, people are moving to other ones. Quay is actually Red Hat offered one, so take a look at that. Everything's built from something called a Docker file. And the whole idea of a container is you package it and you can run it anywhere. As long as you have a container runtime and you have a container, it will run. So as you start building your application out into containers, you need some way to orchestrate that. And that's where Kubernetes comes into play. The most important thing to know about Kubernetes is it is a truly open source project. So one major difference between Kubernetes and Red Hat is that Kubernetes only has community support. Yes, there are platform providers like AKS, EKS, and of course IBM Cloud. But if something goes wrong on the Kubernetes actual infrastructure, if you're running it, you actually have to either talk to the platform provider or they have to reach out to the community. There's not an actual company behind Kubernetes, and that's really important to know. Because when you start looking at Kubernetes specifically, you really realize that it's just a core framework. Kubernetes really doesn't do a lot. The actual scope is very, very small. It's the best way to describe it, and how I've described it in the past, is that if you need to anchor your thought on what Kubernetes is, it's just an API to compute. You give it a container and you say run this container somewhere, and it will find a place inside of its cluster to run it. And you have to realize the platform and the users are responsible to integrate anything deeper than that. So when you really look at Kubernetes, it doesn't do a lot. That's why if you go to landscape.cncf.io, you look at that image and you see that it's exploded over the last couple of years because people have been going into this space realizing, oh, they didn't have this, oh, they didn't have that. So a bunch of open source projects have been created to do that, which is cool. Don't get me wrong, it's good to have different options out there, but it's really hard when you start talking to companies running their business. So that's where OpenShift comes into play. So OpenShift is a Red Hat certified version of Kubernetes that is production grade. So if I had my business out in the world and I needed to choose between using OpenShift and Kubernetes, if I use OpenShift or if I use Kubernetes, I have to do everything from the ground up by myself. So I would have to have the expertise to run Kubernetes or understand it, and things would go wrong. I'd have to go to the community. OpenShift, on the other hand, everything is supported by Red Hat. So if something goes wrong, I can call Red Hat and be like, hey, something's broken on my OpenShift cluster, help me. That is the whole point of OpenShift, is true enterprise support for Kubernetes. There's also some really, really, really nice to haves when it comes to a developer. And I will definitely show that during the demo of this to show you how easy it is to get just a simple application up and running inside of OpenShift without having to deal with all the non-guardrails that exist inside of Kubernetes. OpenShift is designed to give you the true velocity that you need to be successful as a developer. Yes, there are opinions and there are integrations that go, and you have to go by what OpenShift and Red Hat have decided to do. But if you go whole hog into it, you'll be amazed on how many things you can get out of it. Okay, so now let's talk about a deployment. So a deployment is basically so when I said containers was the smallest thing that Kubernetes needs to know about, that's actually a lie. What Kubernetes needs to know about are something called deployments, and that's you declaring to that Kubernetes and OpenShift cluster, hey, I need X running, X number of containers inside of a pod running that way. So as you see here, pod A has deployment replicate of 2, pod B has 1, pod E has 3. You can have n number of containers inside of the pod, as you can see with pod B with 3, pod E has only 1. It just allows you to work on the way your application stack works. The best way to think of a pod is a complete is the stack of your application. So back to the microservices that our friend from Google was talking about earlier. If you had a way to containerize your application and it only did the shipper, for instance, that would probably want that to be one pod. Obviously, there's some philosophical questions there, and like with all engineering questions, it depends, but it's a good way to put your mind around that. So then there's something called nodes. So as you tell Kubernetes or OpenShift, hey, run my thing, what it's actually done, the actual compute that is being run is something called a node. So as you see here, for us as a downstream user, Kubernetes and OpenShift is just one big blob. It's just one big cluster. We don't need to know what node it runs on because Kubernetes figures out that for us. Now there are rules, anti-affinity rules and affinity rules, so you can make sure that if you're doing some ML or something like that, that you get on a node with a GPU. But in the grand scheme of things, all we have is an API to compute, and nodes complete that cluster for us. As a user, you shouldn't really need to know it. Hey, Ron, I'm getting some background noise. Is that you? I'm hearing a lot of beeping. No? Okay.
We'll make sure it's all off, okay? No problem.
Cool, thank you. So, okay, so now that we've talked about how the cluster is created and all the small little entities inside of Kubernetes, let's talk about some internal concepts of Kubernetes and OpenShift. If you didn't know, K8S is the shortened version for Kubernetes. I'm cool, so I, use K8S. That was a joke. Hopefully somebody laughed. Okay, so if you're an infrastructure person or if you're a developer, you've probably run into DNS at some point in your career. Well, unfortunately, inside of Kubernetes, they have DNS also. They have their own DNS. They have their own DNS actually server inside of the cluster. How else are you supposed to know where the different pods talk to one another? So if you take this service, for instance, foo-web, we tell, hey, foo-web, if I have this pod A where only internally I need to talk to my other microservice, foo-web, this little spec right here, which is a little bit cut down, but it's the general idea of it, you tell Kubernetes, hey, this foo-web, you map port 80, port 5000 on any pod C. As you can see, pod C tick here. So the idea is, if I need to find pod A to talk to pod C, I go through foo-web. It's a lot more complex than that, but in the general way of you declaring where your endpoints and what things are happening inside of Kubernetes, you use a kubedns and create something called services. Hopefully that makes sense. When you take the next step, when you start putting everything together, the next thing you need to think about is something called namespaces. Inside of vanilla Kubernetes, there's a term of namespaces. Namespaces are basically walled gardens. So as you can see here, I have my application and your application. These are the exact same applications, but they cannot talk to one another. That's not 100% true now. Over time, there are ways to have things bleed in and over namespaces, but that's out of scope for this conversation. What I want to make sure that you get across to understand this is that you can have namespaces that are completely isolated. That also can work with affinity and anti-affinity rules, which allows you to have dev, QA, and prod all in the same cluster, being able to talk to the same things if they wanted to, and be able to actually test things out. It allows you to cut and slice up your Kubernetes cluster to be what you need. But you take it one step farther, and OpenShift has this term called projects. Now, projects, another good way to kind of grasp onto the concept of namespaces is that a project is a lot like a Git branch. So when you are using the Git process to deploy applications or to write code, you normally create feature branches to do certain things. Well, projects are really, really strong ways of spinning up ephemeral namespaces to be able to do some tests, figure stuff out, and then have real RBAC on it. And then you can roll it back into your master or your main branch if you want. So take, for instance, I'm this developer here in the center. I'm just a developer. Obviously, I have RBAC to talk to dev, but I can't talk to anything else. But eventually, if I have dev today or dev today's date, I could be working on something, get to where I like it. Then I can take that code, push that up into the next release of the branch or the code or whatever, and then we can push it into prod. Projects have so much power and so much niceties on top of it that it really does augment the way modern day developers work. It has a really nice kind of process to think about. And we'll be playing with projects here in a little bit when I bring up the demo. So when you've created a service and you're like, hey, Foo Web, where are you? And where do you go? There are multiple different types of services you can have. The majority of the ones out there you see are load balancers because you can have n number of pods on behind it. So think of it this way. I talk to an external IP of Foo Web. This can also be internal. And then it'll load balance between all the different pod Cs we have. This also has the advantage of many different knobs and dials. Actually, you can have your own whole talk about the load balancer spec for services alone. I strongly suggest looking at docs.kds.io to really dig into it. And there are other ways to rip things out and change things around. So it's very, very powerful. But you'll see the majority of services out there being load balancers. The hardest thing to understand inside of Kubernetes is something called an ingress rule. An ingress rule is basically another service where it maps out your whole application stack. So if I have this host of this machine, if I want to go to /, it will send me directly to port 80 on our front end, for instance here. And if this is our data plane, if I went to /data, it would actually tell me to go to port 3000 if I was coming in from the outside world. It's really important to know because as you move forward in vanilla Kubernetes, your ingress rules become more and more complex. And if you didn't know, this is all YAML. So if you have one space wrong inside a YAML, you could literally be debugging it for hours on end. I may have had that problem happen to myself, and this is not a joke, but it's supposed to be a little bit funny. I was up at 3 in the morning trying to figure out why there was a space that wasn't supposed to be there. So needless to say, there should be a better way to do this. And that's where routes come into play. Routes are actually an OpenShift concept that comes from one of the original versions of OpenShift, and it really does extend ingress away. So no longer do you have to deal with this whole YAML file that's usually significantly longer than what I have right here. You now have literally 3 commands that you say, OpenShift, hey, create me a route. Hey, OpenShift, expose my route. Hey, go do your thing. And then all of a sudden, it just works, which is unbelievably powerful when you start thinking about not having to waste the cognitive overhead to make sure that your ingress rules are correct and all. OpenShift just does everything for you. And we will see this here in a few moments. So let's take a quick step back. And now that we kind of see how all the different pieces, and hopefully you've kind of gotten an idea of Kubernetes being a shared API to compute, and OpenShift giving you some really nice things on top of it to make things better. We'll start talking about the ecosystem because, as I alluded earlier with landscape.cncf.io, the ecosystem is massive because of all the different requests for it. I'm going to highlight a couple of the projects here just to kind of make sure that if you are walking into this world, you at least have some idea when somebody uses these terms. The first thing we need to talk about is Helm. Helm has become the de facto standard of being able to deploy upstream applications into Kubernetes and/or OpenShift. It's a templating language on top of all those crazy manifests and the ways you do your deployments, and it's extremely powerful. I strongly suggest spending some time with Helm to understand how it works. But as a downstream consumer, most of the time you just need to play around with some knobs and dials, something called the values.yaml, and you'll be able to get that application up and running. So Helm is based TLDR. Helm is an application, not a packaging per se, but a way to get other applications onto your Kubernetes clusters in a standardized way. The next one I want to talk about is Istio. You may see this come out. This is something called a service mesh. So as you start building your application out into microservices and really taking advantage of all the different pods and the ways your application works inside of Kubernetes, you need some way to be able to switch little bits and pieces out without taking down your application. Or you need to get some debugging between all the different pods and things. You need to understand what's happening. Or for that matter, you may even need secure communication between different pods, so people can't jump across and or do man-in-the-middle attacks. If you have a Kubernetes cluster that goes over multiple clouds, things like that. That's where Istio comes into play. A service mesh is a very deep technical conversation that is way out of scope for this. But the best way to get your mind around a service mesh is it's basically a way to control communication between pods and be able to debugging things. And also a nice bit of trivia, Istio means sail, as in this thing right here, in Greek, which I thought was kind of cool too. So the next step, as our friend from Google also mentioned, there's a thing called Knative out there. Knative is a serverless application stack on top of Kubernetes. Serverless is obviously a very hot topic, and there's a lot of opinions and ways of going around it. Knative is a natural way for leveraging the Kubernetes ecosystem inside your Kubernetes cluster to be able to get serverless running there. Again, that's actually its own conference in one thing, Knative. So I'm not going to go deeper than that. But if you need to understand what it is basically the serverless platform inside of your Kubernetes cluster. I wonder why they didn't call it K-serverless, but that's just me. Again, that's supposed to be a joke. Hopefully somebody smiled. Okay, so now that we've talked about all these different things, let me actually show you how easy it is for all this stuff to come together. And let me go ahead and say and apologize ahead of time if anything embarrassing pops up on my laptop as I'm showing this. It is mainly due to I forgot to hit something. So I have this nice Cloud Native Python example app repo on GitHub, and I have this amazing application right here. If you can see here, it says it's a Flask application using Python, and it returns hello world. So obviously it's version 1. It's going great. We're gonna go ahead and do it. So what I'm gonna do first, and just to make sure everybody's seen this before, I'm gonna go ahead and build docker build -t angel beats.
JJ?
Yes, sir.
As you type that in, one thing I want to do is announce the winner of the $100 gift card, Chip Licksweck with Exelon. So Chip, just email me directly afterwards and I will send you the $100 gift card. We appreciate everyone listening in to our great Angel Beat session featuring JJ and IBM. And I know once you get through this, I know Mark from Horace Mann Insurance had questions about OpenShift and is it equivalent of AKS or EKS and how all these things tie together with Dockers and Kubernetes. And you can look at that, or we could answer it offline separately.
No, actually, while this is building, this is a great opportunity to answer that. So EKS and IKS and IKS, all those offerings are vanilla Kubernetes. So that is just like a Kubernetes cluster that runs out there. OpenShift is a production enterprise grade version of Kubernetes with a bunch of really niceties to have onto it. So as you can see here, as I'm building this container, which by the way was supposed to be a lot faster than this, what I'm going to do is by showing the exact same code on my laptop, when I run it to show you that this is how it is, I push this up into a infrastructure, and we're going to leverage portions of OpenShift to get this application already running on the actual internet here in just a moment. So this is the actual, this exact same repo right here. And as you can see, hello world. There's a few other things inside here, but we're just going to play with this for now. And then what we're going to do And this is actually OpenShift right here. On IBM Cloud, it looks like this. And then you create this web console and you have this here. So what we're going to do first is I'm going to come over in here and I'm going to create a project. Again, as I said earlier, projects can be ephemeral. You can have production level things inside of it. You can also do projects for just today. So what I'm going to do is I'm going to call one Angel Beat, right? Because that is where we are and that is what we're going to do. So I'm going to create this project. So as you can see, there's nothing inside of it right now. You know, no deployments, no pods, nothing. There's a couple of secrets just because that's by default. So what we're going to do is we're going to take this same pod. If you're right here, Docker run, and then we call this Angel Beat. So we run this. Oh no, oops. It's port 8080. Just to prove to you that this is a container and it's working just how I expect it to. So if I go here and I port 8080, it's running on this. So if I go into our example here, local host port 8080, we see hello world, right? And as you can see, we actually had communication here. So we know we have this container running. What I will do now is I will do GitHub or git remote-v. And as you can see, it is on GitHub and it is the exact same repo. And just to make sure that there's nothing up my sleeves here, git push, because that's nothing there, everything's up to date. So now we can say that, oops, where is it? We can say that this code right here is the exact same code we ran on our laptop. So I've now had I have a container that I know that it works. So let's get OpenShift to play with this. So what we'll do is we'll take this and we will go into just one brain dead. And we'll go into a build here and a build config. So what we'll end up doing is we'll create a build config. You can also do this. Oh, whoops, sorry. Let's actually do this from the command line. So what I will do is I will log in here. And don't worry, if you steal this later, it won't work because that's the beauty of security. It will actually take it away after the fact. So I will log in, and as you can see there, so I'll do OC project Angel Beat. And as you can see now, we are now using that exact same project. So OC new app. And then what we'll call this is Angel Beat. Oh, wait, hold on. New app. Oh no, it's not in my thing. So what I'll do there we go. As you can see now, could not find the local. It says, hey, we're going to create a deployment called Angel Beat. And it looked for this there. It actually discovered a new service and then actually put this together for us here. So if we do the logs, oops, you'll see now that build config was created for us. Did a bunch of nice things in here. The most important, the thing that finally got me across the board, and it already figured out that it was the Python 377 Slim. I will take this URL right here, come over here, go to settings and webhooks. I will create a new webhook. Come on. Come on. Come on, computer. Do your job. Confirm that password. I will take this. I will paste that URL in there. I will turn this into JSON. I'm going to make this small just so we can see everything. I'm going to go ahead and add this webhook. We're going to go back to this guy. As you can see, we already have our green check mark. So that means now we have GitHub now knows about our OpenShift cluster. So I can come back over here now and look at our workloads, so our pods. We are still building things, it looks like. Give me 2 seconds here. Workloads. You know what, let's go into the developer view. There's less things going on here. So something's broken. Hang on. Oh, it's because we haven't pushed the code. So if I do, if I come back over here and I say vim app.py, and let's go ahead and say angel beat. There we go. Git add that. Git. I'm going to be bad and commit to master. Git commit -m angel beat. Push that out. We should see over here in the builds in just a second here. Don't make a liar out of me. Should be builds. Oh no, it failed. What did I do wrong? Oh, my mistake. So what I did was, if I go back to the build here in this build config, I put the this URL right here is SSH. We need to do it as HTTP. So if you come over here, that's my mistake. I'm so sorry about that. I'll go ahead and push this in there. I will save that. And then let's go ahead and do another change. Vim app.py. Hello, Angel Beats. I swear. Git add app. Git commit -m. Again. Oops. Git push. And just to, while this is going, I will also do the build on this container. Oops, build, just so we can see that when it comes back over here, and we'll see on both sides. So if we come back to topology, this is, it says image build packoff mainly because it's still doing its build right now. If I come back over here into builds, there we go. We're still running this build just as we were doing earlier. This should look relatively familiar. There we go. And give it a second. Ron, are there any questions while this is going?
I will check. I think, let's see, is route the CRD in OpenShift? That's one of the questions. Maybe you could comment on that.
Yes, so what we'll see here in just a moment, with this Angel Beat route will come out here, or actually it won't. I need to turn that on, which will be fine. That was that expose command if we saw it earlier. This right here, I will do that to kind of show what's going on here in a moment. Give me a second.
That's coming from Softility, which is a huge developer that will hopefully be able to leverage these tools for their clients.
Wonderful. So let me go ahead, and I'm putting this on another screen so I don't forget to do that. So that's still doing that. And then if we come back over here, it is still building. Still running. Okay, so as you see here, this pushed successfully into the internal registry. As you see, there's just like Docker Hub or Quay, OpenShift has its own built-in registry to make sure it doesn't need to pull anything from the external world. So if we come back over here, and then we go here, there we go. And as you see here, we have the service port 8080, and then there is our actual successful build. So what we'll end up doing is we will go ahead and when this is done, perfect, I will go ahead and expose. Oops. Expose that Angel Beat. So we should now see, there we go. Here's our route, just like that. Oops. Oh, oops, no, this is not Angel Beat. We want to do this one. My mistake. There's a lot of moving parts, but as soon as you get your head wrapped around it, it really makes a lot of sense. Cloud, native, TIV, Python, example, app. There we go. So now if we scroll this down, there we go. That's what we're expecting. And then we should be able to go here now. There we go. And there's our code. Hello, Angel Beat, I swear. So that means now, if I come back over to this repo here, just as I said earlier, there is a hello, Angel Beat, I swear. And then there's our code. So we can now make a change here by going here and being like just hello, Angel Beats with 3, commit those changes. And come back over here, we'll see that already it was like, hey, something changed. It's kicked off the build. That's something we're not going to talk about. We're just going to look at this guy now. And what we'll see here in just a second, come on, don't make a liar out of me. We will see it roll this for us. You can do a lot of different interesting things around the rolling to make sure that, you know, things come up how you expect it to. If you have like a Java app or something like that, you can make sure that Java starts inside the container before doing the full rollout. You can also do a lot of neat tricks with it, but right now we only have a static hello world kind of app, so we don't have to worry about too much around there. Come on, don't make her lie out of me. What are you doing? It's been done by now. Still going. And while that's going, I'll go ahead and just, again, just if I was doing multiple teams here, hit pull. I pull down the change. So now if I look at app, there we go. We've gone back to hello, Angel Beat. And then I can do the build again. Let that run. Shouldn't take too long. Come on. Got a minute. Come on. Still going. Why is not supposed to take so long? The demo gods, right? I'm trying to do a live demo. Of course, things are going to take longer than I expect them to.
Well, I think JJ, a lot of what you're doing.
There we go.
Oh,
there we go. It's already created it. It's done the roll. And come on. Maybe. God, come on. There we go. So as you saw, we already saw that nice little GUI. And then we can come back to this one. And I swear it should be gone. And it is. Hey, there we go. And to be completely, just to prove again, if you wanted to see it, I can run the build on the local machine to see that it actually does the same thing, because it's the exact same code in both places on my laptop, also pushed into OpenShift, all through using Git and GitHub and webhooks. So now, instead of me as a developer, I don't have to think about the infrastructure. And that's the ultimate goal here, is that as someone who uses OpenShift, specifically OpenShift, and having all these niceties around it with the CI/CD, with the ability to spin up routes and things like that, where you can change these routes to be easier. Like I could have like asghar.labs.io if I wanted to. This is just the default one from IBM Cloud. As a developer, I can now focus solely on my code and then push to main if I want to, or if I need to do a new rollout or something like that, or have a different project that has maybe a feature that I needed to push out. So I can make the changes and have my other team members be able to look at it or run tests against it in an isolated way using projects.